All right. I think it's recording. Should be recording. Okay. So which ones do we have questions about? Yes. The answers were all on my webpage. Yep. Yep. I am serious right now. I'll be serious in 3 minutes too. Because I thought maybe some people in sixth period, since they're not going to see me today, maybe they would want to go back and see what we did, what we would have done. So, questions. Which ones do we have questions about? Number 6. I need to minimize that guy. And I need this. Let's blow this up a little bit. There we are. Okay, so number 6, probably a non-calculator question. I would assume, by the way the answers look, that it's non-calculator. So, let's see. Area bounded by the curve e to the 2x, the x-axis and the y-axis. Let me white out those lines. That's bugging me. Where's my pen? There it is. Okay. Do y'all know what the graph of e to the 2x looks like? You should. You should. Okay. E to the x looks like this. Do you know what e to the 2x would do? It's just going to be a little bit steeper. It's technically narrower. It's not steeper. It's compressed horizontally, which squeezes it closer to the x-axis, so it'll actually look like this. It's not getting steeper, it's getting narrower. But the end result is that it's above the x-axis, which is all you need to know, because the problem says we're bounded by the curve that, both axes, and the line x equals 2, which would be here, and we're looking for this area. How would I get that? The setup, I mean. Pretty easy setup. Should be an easy setup. Aw, man. I lost my whiteout. What's our setup? It'd be 0 to 2 of the function e to the 2x. What is the antiderivative of e? What is the antiderivative of e to the 2x? No, it's not 2e to the 2x. That's the derivative. This one is e to the 2x divided by 2. If you wanted to u sub it, you let u equal 2x, and you would go that route. But I did tell y'all a long time ago, if it's recognition, if that 2 was not there, this would be straight up e to the x, right? Right? If the only thing keeping it from being recognition is they have a number in front of the x, so in this case, like a 2x, if they just have a number in front of the x, then you keep that number, but you then divide by it, right? Right. So I told y'all that. Then it's 0 to the 2, and then we just plug in. E to the 2 times 2 would be e to the 4th divided by 2, minus e to the 0th would be 1 divided by 2. And now I'm starting to look at the options, and they didn't even combine it. Oh, wait. Yeah, there it is. They could have made it e to the 4th minus 1 over a single 2. There we go. We good on 6. We good on 6. 3. Oh, it's over here. Aha! This is like keeping all the lines. It's bugging me. Am I still recording? This is going to be so exciting to watch. Okay, so we have this integral, and they tell you the answer is 16, but we have to solve for k. One option, which would be painful, is you could just plug all those numbers in for k and work out all 5 problems and see which one gives you an answer of 16. That's a brute force approach, which if the answer is E, it would suck. What is the answer, by the way? So D. So you'd have to go all the way to D to get that. That'd be miserable. Okay. So this one, we're going to just do the antiderivative. The antiderivative of x to the 7th is x to the 8th over 8. What's the antiderivative of k? It's kx. K is a number. So we're doing that antiderivative like if it were plus 6. The antiderivative of 6 would be 6x. So this is kx. It's not k squared over 2. We evaluate that from negative 2 to 2. Right. And then we plug in. So 2 to the 8th over 8 plus 2 times k, plug in negative 2, so negative 2 to the 8th over 8 minus 2 times k. And what happens here that's so beautiful? Yeah, these, which is kind of scary and intimidating, 2 to the 8th, 2 to the 8th, and negative 2 all to the 8th are the same, and we're subtracting them. So those cancel, and we're left with 2k minus a negative k, and we get an answer of 4k for evaluating the integral, but they tell you the answer is 16, and so k would have to be 4 to give you 16. Are we good? How does that make you feel? Moving on. What else? What else? 14. That was the hard one, according to the AP folk. Oh, yeah, I guess so. I guess so. So let me grab that picture. Oh, it's putting all these stupid lines in it. Did I get lines that time? Oh, I got the... I didn't want that. That's annoying. I'm going to have to do this again. Scroll down some. Okay, that's better. Okay, so we have this region. That's the line. X plus 2y equals 8. Cross sections perpendicular to the x-axis. So we're cutting it here, perpendicular to the x. What does that mean? It's a dx problem. We are doing volume, and I always go through those same questions. What shape are we dealing with? A semicircle, and we know that because it tells you, right? It is a dx because cross sections are perpendicular to the x's. The area of a semicircle is half pi r squared. We just need to get our r in terms of x. So what would radius be if my semicircle is sitting here perpendicular to the x? Ooh. What do we need to know? Uh-oh. Are we completely lost? Are y'all mad because we're getting out of school early? Is that why we're not talking? Silent protest? Yes, I need to get this equation in terms of x, and if you solved x plus 2y, if you solve that for y, it'd be 8 minus x all divided by 2, right? Y'all want to STD that? Make that 4 minus 1 half x? So 4 minus 1 half x. Are we good? Are we good? So my semicircle is looking like this, and that's coming off the screen at you. Try to imagine that semicircle is coming off at you. The radius is only half of that distance, right? So the radius is this. So how would I get the radius? We did one like this Friday, didn't we? The function, if you go all the way from the x-axis up, that's your diameter. The radius is half of that. So my radius is going to be half of 4 minus half x. Are we good? Are we good? The whole distance would be the diameter, so that's half of it. Then, for the integral, I need to do 1 half pi, antiderivative, of that radius squared. So 1 half of 4 minus 1 half x all squared, and then limits of integration would be 0 to 8, because it is a dx problem, and you want to make sure you're going along the x-axis. What would we do next? What would you do next? Normally, yes. I would not. Nope. Look at the answer choices. What do you think I'm going to do? Put it in your calculator, right? You have the skill set to do this by hand. You should be able to do this by hand, but it's a calculator problem, so don't, right? Take advantage of the calculator. Plug that in the calculator. What is the answer to this one? C. So throw it in the calculator. Just be very careful, because I bet you one of these 5 options is what you would get if you did not put 1/2 pi on the outside. That's probably one of the options. One of them's probably, is one of them exactly twice that? No, okay. So they didn't put one that was only pi, r squared. What else are the common errors? Forgetting the squaring it? I don't know. I bet one of the answers is if you don't put the 1/2 in and you only do 4 minus 1/2 x. Is there one that's 4 times that? Yeah, that would be D. So if you forgot the 1/2 in your radius, then you get D. They know what mistakes you're going to make, and they're going to prey on you. Any other questions on this one? Other questions on the homework? Other questions on the homework? No? We understood all of it? Any of them? 15 was hard? Oh, yeah, it's a cross-section thing. Never mind. Well, if we don't have any questions, I guess we can look at the study guide thing I gave you, or some other free response questions. And the answers to these are here. And so if you want to look at some of the other ones that I didn't assign, there are some good free response questions here as well, and answers to the free response questions. So this would be a good source of things to look at. So where do we want to look next? Do y'all want to look at the review thing I gave you? Or would you like to look at those free response questions? What would... Two. Same as always. Hold on. I think that's y'all, isn't it? Okay. So I guess I can start recording again. So the review on the answers, I believe that when it was possible, I also worked volumes with shells. Yeah, so if you see anything with shells, just ignore that part. It's a different way of doing volumes, and you don't need to worry about being able to do anything with shells. So just, yeah. These are good pictures. I'm quite the artist. Okay, so Naomi, what you thinking? Oh, that was a thumbs up. Okay, I thought you were asking a question. Alrighty. So where do we want to look? What kind of questions do we have? Do y'all want to look at a free response question, or? Okay, so which one? There's one right here. I'm not a big fan of that one. There are also free response questions on this A+ thing that we were looking at for homework. Do y'all want to look at some of those? Let's do some of those, because these are good questions, I think. Let's do... Sure. I wonder if 2011 is calculator. Not sure. 2009 4 would not be. This one is. Let's do this one. I like this one because it kind of looks like a bird without wings flying to the left. I don't know why. A whale? Okay, yeah, I guess so. I see the whale now. Where is my camera? There he is. Okay, so this problem from 2008, number 1, this is a calculator problem. Let's see, let me grab the picture of the region. Okay, on the area volume questions, if you get one on the AP exam, they typically start kind of nice. Like question A is just a straight up normal generic find the area of the region. It is a calculator problem, but even without the calculator, you should be able to deduce that x cubed minus 4x is the one on bottom and the sine x is the one on top. And so I guess I'll go ahead and label those. So the top one is y equals sine x. Sine pi x. The bottom one is y equals x cubed minus 4x. Okay, so what would the setup be for A? It should be an easy setup. How would I find the area between those two? somebody open that for me, please? It'd be 0 to 2 of the top sine pi x minus the bottom. Please make sure you watch your parentheses, because if you don't put parentheses around the x cubed minus 4x, it's wrong. So the area between two curves, it's either top minus bottom or right and left, and this one's a top and bottom. Don't forget to write the dx. And what's the next thing we're going to do? Plug it in the calculator. Again, you have the skill set to do that without a calculator. Don't. You don't get any points for doing the antiderivative by hand if it's a calculator problem. All your points come from this. You probably get, I don't know, with this having 4 parts, you probably get 1 point for the setup and 1 point for the answer. A lot of times they'll give you 1 point for getting this part right, 1 point for getting the limits of integration right, and then 1 point for the answer. If it's a non-calculator problem, then they would obviously give you a point for correctly getting the antiderivative before evaluating. So do we have an answer for this one? Has anybody punched it in yet? We do know how to do this in the calculator, right? I'm going to go ahead and fire up my calculator too and get this thing going. Let's pause the recording. Where's my menu? Escape. There we go. All right. Whoops. Okay, so we're punching in the equations. It was sine pi x, is that right? Sine pi x, enter. And then I also need to put in, was it x cubed minus 4x? X cubed minus 4x. Ah, son of a, let's get out of there. Minus 4x. Okay, and I'm going to go ahead and adjust my window. The problem, what is it, -3 to 1 and then 0 to 2. I like to give myself a little bit of breathing room, so instead of going -3 to 1 on the y-axis, I'll go maybe -3.5 to, was it to 1? To 1.5. And then what were the x's? 0 to 2. So I'll go like -0.5 to 2.5. Just give me a little bit of breathing room so I can see things better. So there's our region. Move that up here. And let me go to my compute screen because I needed to do the antiderivative from 0 to 2. And because I have them stored, I know it's f1 of x minus f2 of x. And double check if you're going to do this in the calculator and use the f1 of x notation, which I strongly encourage, make sure when you punch in your equations, do a double or triple check and make sure you play. Oh, that's sexy. I wasn't expecting a nice clean answer. Isn't that nice? Double check and make sure that you get you plug everything in correctly, because every test there's somebody who has beautiful setup, but all of their answers are wrong, and it's just because they stored something incorrectly in their calculator. So make sure that you don't lose points for programming errors. Yeah. Okay, so we just get a nice answer of 4. How clean and pretty is that? Unfortunately, I think that's the only clean and pretty problem. Number B, the horizontal line, y equals -2. So I'm going to come down here and graph y equals -2. That's going to be right here. Divides the region R into 2 parts, right? But do not evaluate. That's a fairly common thing also. So on this one, don't plug it in the calculator and get your answer. You just need to set it up. We want to find an expression for the area of R below the horizontal line. So I need to find this region. How would I find that area? It's definitely going to be an integral. I can do most of it right now. It's going to be a top minus bottom, and the top is y equals -2 minus the bottom, which is x cubed minus 4x. Right? That's probably 1 point. What would the second point be for? Yeah, we need the limits of integration. I need to know where this region begins and where it ends, and that we don't know. That's not given to us. They probably will not give you points for the limits of integration on part A because it's already there. Like, you didn't have to do any work to get them. We have to do work to get those. So how do we get those limits of integration? You have to find the intersections. I'm going to go back to my calculator, and I need to graph y equals -2 now. So let's graph -2. There it is. Menu, analyze. Okay, now when I hit intersection, what's the calculator going to do? It's going to ask which two graphs you want the intersection for. Because if there's more than two, you have to pick them. So the first thing it says is graph. So we have to pick a graph. And then it says second graph, there's the second one, and now it knows where to look for your intersection. So we have one intersection at 0.539, and the other one, menu, analyze, intersect. Pick the graphs again. And the other intersection is, oh gosh, 1.675. Guess what I'm going to do with those? I'm going to store them. Now, I probably don't need to, but it only takes a second. So I'm going to click Control Store. Why do you think I don't need to bother storing them? What were the directions on this question? It said write, but do not evaluate. So we don't have to worry about preserving accuracy in the answer because we're not going to get the answer. Well, actually, we are. The answer is just a setup. So the intersections, now I forgot. 0.539. And the upper limit is 1.675. And we're done. We're done. Yes, yes? So that wasn't bad. What about C? The region R is the base of a solid. For this solid, each cross-section perpendicular to the X is a square. So now we're in those known cross-section things. So if I cut it perpendicular to the X, so I'm cutting it this way, it's a square. Same questions I always ask. What shape? Square. What variable? dx. What's the formula for the area of a square? Very good. Side length squared. We just need to get the side length in terms of x because it is a dx problem. What will the side length be? So there's my side length right there. My side length from top to bottom, right? That distance is going to be my top curve minus the bottom one. So my entire side length is sine pi x minus the bottom curve, which is x cubed minus 4x. Yes, yes? Then we throw that into the integral. Do we have to solve it? Yes, it actually wants you to find the volume. So then the volume is going to be the antiderivative from 0 to 2. And watch your parentheses. We have to square that whole thing. So it's all of sine pi x minus parentheses x cubed minus 4x. If you want to distribute that negative through the parentheses, you can. Not really needed. So it's all of that squared, then dx, and then we throw that in the calculator and write down the answer. Good. So to the calculator, back here. You know what I could do? I'm lazy. That was my side right there, f1 minus f2. I'm just going to go in here and square it. Oh, I have to put more parentheses. Probably would have been quicker just for me to type it all in. So parentheses. Did I put parentheses? There. Close parentheses. Oh gosh, how many parentheses are there? Whatever. Squared. Control enter. I always hit control enter just because it's out of habit. I got 9.978. If I didn't hit control enter, I wonder if I would have gotten a decimal. Oh gosh! Okay, that's fine. If you want to write that, you can, but on a calculator question, I would much prefer the decimal. 9.978. Yeah. Yeah. How do we feel? How do we feel? Good, bad, ugly? All right. Let's see. I'm gonna. Yes, sir, Ethan. It's it's not. I know where you're going with it, but yeah, it's yeah. I don't have an answer for that. With it, that wouldn't like I could answer the question, but it would probably take me 20 minutes. But yeah, squaring the function does not necessarily square the answer. As you see here, we went from 4 to 9.978. All right, so D. I do think parts A, B, and C were fairly nice. Those are what you consider straightforward, traditional, no curveball type questions. But they will, on almost every free response question, or most of them, will ask you one question that's really kind of bizarre, and this is it on B. The region is the surface of a small pond. So imagine we're in a helicopter and we're looking at the surface of a pond. If you are X units from the y-axis, so however far away you are from the y-axis, the depth of the pond is this. So that means that at the very beginning, when my x-coordinate is 0, what's the depth of my pool or pond right here? It's 3, right? Because it's 3 minus the x-coordinate, right? If x is 1, at that point, the depth is 2. And when x is 2 at the shallow end, my depth is 1, right? So it starts 3 feet deep or whatever, 3 units deep, and then it gets shallower as we go to the right. It wants to know the volume of the water. Any wild guesses? No? You want me to reword this a little bit so it makes so maybe it'll make sense? I'm going to slowly reveal stuff to you here. This is a cross-section problem in disguise. It's very similar. The setup is going to be very similar to the approach we used in C. It's a weird cross-section type question. Let's imagine this pond is frozen. If I were at any point, like right here, and I'll just look at this spot in the middle, right here in the middle where we said the depth is 2, that depth of 2 is consistent the whole time, right? So if I were to freeze this pond and cut out a little sliver like that and pull it out and look at it, do you have any idea what shape that would be? Not necessarily a square, it'd be a rectangle, right? Because the depth right there is consistent, right? Right here, what shape would this be? It's still a rectangle, it's just going to be not quite as deep, right? And over here, we have rectangles here, but they're going to be a little bit deeper, right? So what we have here is a known cross-section situation where we can go through the exact same questions we always ask. So on D, what shape are those cross-sections? They're all rectangles. What variable would I use? It's an x. We're perpendicular to the x-axis, right? What's the formula for the area of a rectangle? Yeah. Now this time we have to go base times height. We can't do side length squared because it's not a square this time, right? So what would the base of my rectangle be? So I would consider that dimension the base, right? So that distance, that is your base, and that's the same that was the side length for the square. So sine pi x minus x cubed minus 4x, right? And what about the height of that rectangle? Yeah, that's what they gave you up here. The height is 3 minus x. So now we have the base and the height in terms of x, and we'll do the antiderivative. The whole base, make sure you grab that in parentheses, sine pi x minus x cubed minus 4x. So there's the base. The height is that h of x function they gave us in the problem. And we're going to measure this starting with x equals 0 and ending at x equals 2. Does it want the actual answer? It does want the actual answer, so we do need to punch this in the calculator. Here, let's at least record and show that answer. There's that answer. Threw that in the calculator. And make sure you round to 3 decimals. Okay, so from 2011, and y'all don't have a hard copy of this. Let's see, this is a calculator problem. A cylindrical can of radius 10 millimeters is used to measure rainfall in Stormville. Now that's just cheesy. The can is initially empty and rain enters the can. Ooh, this sounds like a rate-in problem. I wonder if they give you a rate of evaporation. Oh, I bet that was D. Anyway, rain enters the height can be modeled by this function S. Okay, notice what they're giving you here. They tell you that the height is measured by S. Why didn't they just call it H? That's just stupid. Maybe the S is for stupid. Okay, so S is the actual height. S is the actual height. And I encourage you to do little notes like that to yourself. You may not feel like you're accomplishing anything when you write that stuff down, but I promise you it helps you process the problem, even if it's on some subconscious level. So write stuff down. We are working from 0 to 60, and S prime would be the rate at which the height changes. So they actually give you the derivative, S prime, and I'm going to go ahead and throw that in my calculator because I will probably need it. 0.03x plus 1.5, is that what it was? And again, double check and triple check to make sure you plug it in correctly. So 2 sine 0.03x plus 1.5, 2 sine 0.03x plus 1.5, and I feel good about that. So I'm going to hit enter, lock that in. I don't really care about the graph right now. According to the model, what is the height of the water in the can at the end of the 60 days? They want the height of the water. How would I do that? Yeah, yeah. We have the rate. We want the amount. That's an area question. 0 to 60 of your S prime, and because they called it S prime, you can actually put that in your work. You don't have to write down the equation. The next thing you write down is the answer. Are we good? We good? Now, did you think about the initial amount? Because you should have. Technically, it's the height at 60 is going to be what I started with plus the change from 0 to 60, but the can was initially empty right there. And so S of 0 is 0, meaning we don't really need it. Does anybody have an answer? Has anybody punched it in? I encourage you, even if you know how to use the calculators, I encourage you to use them as much as possible because you've got to learn, if nothing else, how to troubleshoot. If something goes wrong, you've got to figure out how to fix what went wrong. And you will, at some point, do something funky. Somehow, I don't know how it happens, but people always, on their graph screen, on their entry line, I see people all the time who are, where's the, bless you, where's the relation option? I don't know. Whatever. Hey, some people get into this weird entry line thing. Okay, so there's that one. I don't really care to punch it in. I will later, maybe. Okay, according to the model, what is the average rate of change in the height of the water? Average rate of change. That is a phrase. That is the phrase that you learned in pre-cal. Do you remember what average rate of change means? What do you say, Naomi? I think you're right. Yep. Okay. Average rate of change is your old-fashioned Algebra 1 slope. Rate of change always means slope. Whether it's average or instantaneous, it's always a slope. Average rate of change is f of b minus f of a over b minus a. Except in this case, it's s, not f. So instead of doing f of b minus f of a, this is going to be, where over the whole 60 days, it's going to be s of 60 minus s of 0 over 60 minus 0. Do we have s of 60 and s of 0? Yeah, because s of 0 was 0. S of 60 is our answer to part A, which I guess I'll do that now. 71.813. 171? That's a lot of rain. Maybe that's why they call it Stormville. What are we measuring that in? Oh, millimeters. I was thinking inches. Okay. Not as much as I thought. So Stormville is not very appropriate. Anyway, that over 60 minus 0, slap in calculator, get an answer. Are we good? Are we good? Now, the reason this problem popped up when I asked, when I was searching for average rate of change problems, not average value theorem, you could, if you don't have that information, if we did not have s of 60 and s of 0, but we did have the derivative, which we do, you could also set it up as the average value of the rate of change. What is the rate of change? How does that translate in calculus? That's the derivative, right? So you could actually work this out as the average value of the derivative, and the average value of the derivative would be your average value theorem. 1 over 60 minus 0, area 0 to 60 of the derivative. It will take you to the same place. So if it's an average rate of change, if you have the original function, you do algebra 1 slope. If you don't, but you have the derivative, you can do the average value theorem. And they both will be, they'll both end up giving you the same thing. What do we feel? How do we feel? Questions, comments? Okay, C is going to be really quick, and then we'll maybe look at something different. C, assuming no evaporation occurs, what is the rate, at what rate is the volume changing when T equals 7? How would we do that? It's actually scary easy. It's also easy to screw up. What'd you say? Yeah. Where's the derivative? They gave it to us. That is the derivative. People will mess this up by doing the derivative of the derivative, right? This function is the rate. Oh, no! It's not as easy as I thought. What is that function? That's the rate in changing the height. Oh, this is asking about volume. That's not the volume. Is it? That's not the volume. Yes, you need to know the volume of a cylinder. How do you find the volume of a cylinder? It's pi r squared h, right? Volume is pi r squared h. Do we know anything? And what they're asking you to do is find the derivative of the volume, basically find v prime at 7. Do we know anything about radius and height? We know the radius is 10 millimeters. Do we know the height of the water? The height was the function s, right? So since we have the radius and the height, I could rewrite my volume instead of pi r squared, pi 10 squared times s of t. It's not related rates. It looks like it, doesn't it? Is that what you mean by one of those things? Yeah, so there's my function for volume, and I want v prime. What would v prime be? It would be 100 pi s prime, right? 100 pi is a constant, so it'd be that, right? And then v prime of 7, we'll just plug 7 into that. So it's 100 pi times s prime of 7, which we can throw in the calculator. What would units be? What are we measuring? It's a change in volume, and volume is measured in, and I think you were saying it there, Danny, millimeters cubed, but we're also measuring it over time. We're doing a rate of change, and our units are days, is that correct? So millimeters cubed per day, whatever you get when you throw that in the calculator. How does that make you feel? Good, bad, ugly? Let's see. Multiple choice number 30. Oh, on the review. Let's see. Number 30. Hadn't we done this problem before? No, we did one similar to it. 30 is a good one. Let's check this guy out. I think I may have cut off some of the answers. Not too bad. Okay, so 30. Region bounded by the x-axis and the part of the graph of sine x between 0 and pi. So what does sine x look like between 0 and pi? Yeah, that's just like the first little hump. Right? So it comes up and does something like that. And here's pi. So we're looking at that part of the graph. I'm just going to erase that. It is divided into two regions by the line x equals k. That's a vertical line, so x equals k. I don't know, put it there. Okay, this next part, we need to translate to a math equation. The area of the region for 0 to k. That can be immediately written down as what? The integral from 0 to k, right, of the function sine x is 1/3 the area of the region from k to pi. So the area from k to pi. So there's your equation. They'd put it in a sentence, but you've got to just translate that into a math equation. And then what would that be? What is this going to end up doing? Let's look at the left side. What can I do with that? Yeah, find the antiderivative. Did I do that right? Okay. Something seems wonky here. Okay, what's the antiderivative of sine x? Negative cosine x, right, from 0 to k. And that would be negative cosine of k minus negative cosine of 0, which would be plus 1, is equal to 1/3 of the same function. So it would be negative cosine k, or x, from k to pi. What is cosine of pi? Cosine of pi is negative 1, so that'll be negative 1 is 1 minus cosine, or plus cosine k. Are we good? And now we need to start solving this, and I think there's a typo somewhere in here, because the options A and B are in terms of sine, and I'm wondering if those should be arc cosine instead of arc sine, because there's no way you're going to get an arc sine out of all this. Anyway, so how would you solve that? Very good. We'll distribute the 1/3. And if I'm going to solve that, I think I'm going to subtract the 1. So 1/3 minus 1 is negative 2/3. I'm going to subtract that 1/3 over here, which will give me negative 4/3 cosine k. Right? Multiply both sides by negative 3 over 4. Right? Oh, this is going to be kind of nice. Multiply by negative 3/4. That cancels all of it over here. Boing, 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 boing. And we get cosine of k is going to equal 1/2. And when does cosine equal 1/2? We should know that. It's at 60 degrees, or pi over 3. We always do radians in this class. Shouldn't say always. There might be some weird problem where they give you answers in degrees, but there we are, pi over 3, which is this option. I'm curious if that was, if the answer is correct on my answers. Let's see. What number was that, 30? These answers are so old. Number 30. No, I had it right. I think the options should have been, I think the options for A and B should have been arc cosine instead of arc sine, so it ended up not mattering. Any other quick questions before we're done? Yes. When's the test? The second, are you okay? Oh. I'm sorry. Here, do you want Erica's pass back from the office? Will that make you feel better? No? Okay. What was that? Oh, the test. We're going to start the test when we get back. Who's out there? We're going to start the test when we get back from lunch Wednesday. And we'll do the calculator part Wednesday, and we'll do non-calculator when we get back on Friday. If you are going to be gone Friday, I think I've already said this, but if you're going to be gone Friday and you want to finish up the test before you go to spring break and whatever, then just make arrangements. We'll take it. You can take it before Friday. Are we good? Hey, if you are interested, study session tomorrow, what'd I say? 12:30 to 1:30? Okay. And hopefully Coach Carter will be through. They'll be through with the ACT at that time. If not, I may commandeer somebody else's classroom and we can answer questions in there or something. All right.